Hello and welcome to the fourth in the session in our series uh, of, uh, of lectures from the Hitchhiker's Guide to Artificial Intelligence. Today's session we'll be looking at the question of architecture, AI and architectural design. This, of course, has been the issue that is been behind all of our discussions so far. But now it becomes central. We have touched upon it in the first session. We were showing some of the work of Clip, where some architectural images have been generated in a very novel way. In the second session, we started looking at the possibilities of how GANs might be used, generative adversarial networks, to generate images. And we had a fabulous presentation by Daniel Bolojan of his Sagrada Familia work. And the last session, we had the next session, we had a session on creativity. Let me get right. Sorry, the second session was creativity, and the third session was on AI, media art, and neuroscience involving Refik Anadol. And today, we have a session on AI architectural design. I'm delighted to have such an incredible range of guests this evening. I would say that Emanuel and Daniel Bolojan are two of the three key people in terms of AI and architecture, along with Casey Ream, who unfortunately cannot be here today. But it's fantastic to have such luminaries from the field. Emanuel is, I should say, he's from the Singapore University of Technology and Design. He recently, about a year or so ago, completed his PhD in machine learning in Lausanne in Switzerland. Prior to that, he had been studying at the Architectural Association in London on the Design Research Laboratory, and he's now a professor in Singapore. I'm also delighted to have Daniel Bolojan here again. Daniel presented his work on the second day, and it has been working, in addition to his own research work, has also been working for Core Pimlau and developing this extraordinary project, Deep Pimlau, which to my mind is by far and away the most significant piece of work in terms of the application of AI to architecture to date. Daniel is still collaborating with Wolf Brix at Core Pimlau, but he also is now an assistant professor at Florida Atlantic University in Fort Lauderdale, and has been very active in terms of giving workshops and things on GANs, and including my students. We're very grateful for that. We were also joined by Benaz, who is really one of the most talented interactive designers around today. She also has recently graduated from her PhD. She was studied at the University of Southern California in the School of Cinematic Arts on the IMAC program, Intervisual Media Arts and Practice, and recently has been appointed to be an assistant professor at California State University, Long Beach. So this is a really a fantastic panel to have together for today. Just to go and put this in perspective, then, this is the fourth session, just two more to go. Well, the difference between today's session and the next session, the Architectural Office of the Future, which is going to be a fantastic session with Wanyu He and Theodoros Galanos, is that today's session is really about more experimental forms of design. To my mind, that the way in which AI enters into the office is going to really be a game changer in many ways. But we'll talk more about that later. And then, and finally, we'll end up with the City of the Future, where we are bringing in Sidewalk Labs also to go and talk about this, along with other some very interesting work from other designers working in the field at the moment. So this is then the sixth session, the fourth session out of six. All of these sessions are being uploaded onto the internet on our website, and they'll be available to be downloaded, to be watched for free. So today, I want to talk really. Well, this is an area that is really captivating the younger generation, the generation of my students. Anyway, they when they've started working in this field, suddenly they begin to sort of see something incredibly exciting on the horizon. This is, as Matthias Del Campo has called it, it's like the first genuinely to 21st century new technique that's been brought into the world of architecture. This is the work of one of my students from FIU, Lija, who was one of the lucky students to have been on the in a workshop that was taught by Daniel Bolojan. And again, this another student, Maria, who is. This is a StyleGAN interpolation based on some images from the Grand Canyon. and extraordinary. What these things are doing, and the kind of animation, the kind of forms that they're producing, is really, it's really captivating them. And as I mentioned before, it's also captivating my students in terms of the lecture series, the seminars that they attend. I found that, and I don't know if this is the case with other people, but 95% of my students are now writing essays about this. This is their world. This is their world because it's the AI is on their phones, on their social media apps and everything. It is everywhere in their world today. Moreover, they are the people who are going to be, they are the architects who will be at the peak of their career when AI really kicks in and begins to transform the profession. So to my mind, there's nothing more important for an educator today than to raise these kind of questions and to prepare people for what is the inevitable revolution in architectural design. Well, it's one thing to be working with this kind of experimental work as a student, and this again is some more work from a studio at Florida International University, and you can do this extraordinary kind of imaginative things that are this is a StyleGAN where the work I think of Core Pimlau and Morphosis have been, let's say, bred with interface with some the Miami skyline, and some extraordinary things are coming out, and captivating and amazing in their own sort of right. But in some senses, they're a bit challenging in terms of the profession of architecture. These are obviously, as I mentioned before, these are two-dimensional images. They are, in some senses, out of control. And while they open up possibilities in the design studio, the next challenge really is how do you move into the world of architectural practice itself? And certainly, practitioners such as Tom Main are fascinated by the possibilities of what can be done in this area, even though Tom himself has hardly really begun to really incorporate AI fully into his office. He's certainly well aware of that and has been following Wolf Bricks very closely in terms of the developments of Deep Pimlau. This is one of my students this is my student Chris, who has been taking some Morphosis buildings and then again using StyleGANs, beginning to sort of imagine possibilities of what it might lead to. And indeed, this is again another example of my students, Nico from the same studio, who has been exploring Tom Main is fascinated by the possibility of combinatorial design, and in his office, they've been exploring how you can use Grasshopper to generate a range of different versions of iterations of previous projects. Well, the next step, obviously, is to go and start working with AI to go and open up those possibilities. And this was a study by my student Nico, looking at how one can begin to explore how you can open up that even further. One of the things that maybe is a bit deceptive about this is that the shadows that are being shown here are, they're kind of splotches on the screen, as it were, and they're not actually shadows as such. And this remains, of course, one of the great challenges that we're facing in terms of the use of AI. How do you shift from the domain of 2D to the domain of 3D? In some senses, one can use it for plans, of course, and architectural representation has often been based on 2 dimensions themselves. Plans, sections, elevations, after all, are 2D. But how do we get to 3D? And that's why, to my mind, it was so exciting to see 2 days ago the astonishing work that Daniel Bolojan has been doing, opening up to the possibility of 3D design. It's almost like this is the next important step to happen here. So this is the work these are the ideas that are really captivating the students that I'm working with. They see this as the next exciting area on terms of the architectural horizon. So, but the challenge to my mind really is, how do you really take this into the office? So I'm delighted to have Daniel Bolojan with us today, and I'd like to invite Daniel to show us some of the work that he's been doing with Wolf Bricks and Core Pimlau on Deep Pimlau. Welcome, Daniel.
Thank you, Neil. Thank you for the invitation. So I'm sharing my screen. Are you able to see it?
Yes.
Okay. Okay, so in this presentation, I'm going to show mostly, or I'm going to focus mostly on the Pimlau project. but I'm also going to show very briefly a few other projects that I'm working on. And generally speaking, in a way, I can say that mostly what I'm interested in, or overall as a research agenda that I have is this idea of how can we make machines, how can we teach machines to interpret, how can we teach them to perceive, to be creative, propose new designs of buildings, or augment designer workflows, and augment designers or architects' native ability. So my interest is very broad in a way. I started initially with agent-based systems, and then slowly I started to move towards statistical learning and AI and so on. And just a second, I have some sound playing out here. But mostly a very common, in a way, theme in this research is this idea of intelligence. So this project I already showed 2 days ago, so I'm not going to spend a lot of time here. But just to briefly state, in a way, what the project is about. This is an ongoing research. It's an ongoing research that looks at the development of neural networks capable of identifying relevant compositional features in samples representing Antoni Gaudi's Sagrada Familia, and also samples from nature. Okay, sorry, I have some audio interference here. Okay. So what I'm interested here in is there are meaningful tectonics defined by Sagrada Familia that are constrained by this kind of very symmetrical, in a way, composition. And the goal here is to try to deploy neural networks in order to liberate this kind of intricacy that you find and the novelty that you find in the tectonical detail, and also the structural property, in a way. So here the goal is not necessarily to create or to replicate Gaudi style. The goal here is to investigate, in a way, the style, this kind of intricacy that you find in Gaudi's work, and then find insights probably, or new strategies how you can design. So those strategies, they could mean like strategies of design or structural strategies. So this was a video that was presented at Venice Biennale. And if you want to see the video, you can access the Italian pavilion, and you can see there the video. So another very common theme in my research is also this aspect of augmentation. So why I'm so interested in augmentation is because I always feel that as humans, we are very constrained. We are very constrained to many things. Like if we talk about memory, if we talk about past experiences and so on, those kind of things, they constrain the way that we understand and see things. And here, this quote from Lysidol, I know that is very quoted, but personally, I take another, or I have another take on it. So after he lost to AlphaGo, he said this: what surprised me the most was that AlphaGo showed us that most humans may have thought are creative were actually conventional. And for me, this is something that I find it very common in also in architecture practice. And that's why I put this chart here. Very often we believe that we are creative, or we believe that we have a very interesting solution. And we are not aware that actually probably we are operating into a local minima. We are not aware that actually we are very constrained, let's say, our solution is very constrained. So then the idea is, okay, can we augment, in a way, our perception then of that design space? Can we somehow use networks to help us expand perhaps those design spaces and understand that we are stuck into a local minima, or right now we are operating at a global maximum? So for me, this is very important, because this quote, I think it's pointing exactly that, yeah? Very, very often we really believe that we are creative and our solutions are great, when in fact they are very conventional. And because we are not able to see outside of that kind of design space that we operate within, that's why we consider that they are creative, actually. So I'm going to go briefly through a project here just to talk about this idea of augmentation of design processes and so on. And then I'm going to show the Pimlau. So here, traditionally speaking, that's how design started. Yeah, we always started almost like from an empty piece of paper, and then you start to draw some thoughts and slowly zoom in a way into the idea that that you're trying to define. For me, in a way, design, when I'm talking about design, I see design in this from this perspective, is this kind of idea of, if you heard of the idea hunting a needle in a haystack, design will be almost like hunting a needle in a flock of birds that continuously changes. And why I'm saying that is because once you take certain design decisions, your design space either is expanding or is constraining. And then you take another decision, and again, you have this kind of contraction and expansion in a way of the design space. So for me, this idea of trying to see, can we somehow use networks to help us visualize and understand the design possibility that we are operating within. Of course, that translates into how we make then our intentions machine readable. How do we encode them in such a way that they are understood correctly by the machine, and then the machine is learning, and it's able to assist us in a way in that design. Yeah. So this is just an example of that, where you start to generate this kind of design spaces, and you start to explore and try to understand certain ideas that you explore there. And then, of course, you can create then these kind of explorers that help you in a way navigate in a way design. So in this case, for example, I had to input about 20 design intents, and then, or not 20 design intents, but 20 examples. And then from there, in a way, the network started to try to learn and understand in a way what the design intent is, and then create new outcomes. So another project that I'm going to briefly go through is this project, Agent-Based Creative AIs. And this project has a methodology that consists in a way of a holistic approach to design processes, in which a variety of interconnected neural networks coupled with agent-based systems are deployed to address different architectural and design tasks. So this is probably also slightly addressing what also Neil was mentioning at the beginning, one of the issues with GAN networks. And let's see how that actually it's explored here in this project. But before we go there, I just want to mention a few other key ideas that kind of drive and drive in a way certain processes in this research. So after he lost to Deep Blue, Garry Kasparov, he began in a way to experiment with different ways of interacting, human-machine interactions, where he was trying to really understand which types of interactions are going to be more effective to improve, in a way, the player competitive advantage.
Daniel,
and how, in a way, this kind of interaction can result in a sort of augmented intelligence. So he found that a mode of interaction defined by a weak human player plus a machine plus a better process, it's superior to a very powerful machine alone. And in the same time, or more surprisingly, actually, it's even more superior to a strong human player plus machine and inferior processes. For me, this is very important, yeah, because I see machines in a way helping us in that aspect, yeah. So as you can see, it doesn't matter that we have a very, very powerful machine. That doesn't mean that it's going to be superior to a very weak human player plus a decent machine and a better process, yeah. So I'm really looking then and trying to understand what kind of modes of interactions are not feasible, but relevant in a way in a design process, and where in a way this kind of interaction should happen between humans, machines, and human machines. So just briefly touching on this, also previous lecture, I talked about this idea of machine creativity defined by Demis Hassabis as interpolation, extrapolation, and invention. And I'm showing this only because I'm not trying to define that or to say that human creativity operates in the same way. Why I'm showing it is just that we have to understand how machines operate, yeah? And also, like when it comes to how you interact with the machine, you kind of have to understand this machine requires this kind of language to be spoken to it, yeah, and or you have to expect from the machine this kind of results or those kind of results, yeah. So that's why these concepts then for me are important in this research: interpolation, extrapolation, invention, because in some aspects of design and some process of design, it might be that you just need interpolation. You don't need a machine that is very creative, like extrapolation machine would be, or even more creative, like a machine that it's capable to invent something. Right now, we don't even have something like that. Yeah, we just have machines, AIs that are very good at interpolation. We have a few AIs that are they start to be good at extrapolation, but we have no networks that are actually able to invent. So here, this process then is defined by three main phases. You have this kind of explore phase, and you have a qualifying phase, and you have the generate phase. And mostly what you're doing here, you're creating processes how to explore, then you have create processes how to evaluate and qualify the things that you explored. And once you have these two phases, then you start to actually generate. So here, this is an example of a design process. This was a bridge project done by my students at FAU. And here you see like all these nodes, they represent different types of networks and different interactions that happen there. So why I'm showing this is because in design, some aspects, they might need to be 3D, but other aspects, they are enough to be just 2D. Yeah, so you don't necessarily need only 3D evaluations, for example. Those are helpful depending on the specific task that you're operating with. But if you're just interested in a way, let's say that some visual in a way aesthetics of something, you don't need necessarily a 3D object to understand the visual aesthetics of something. So you can use easily 2D networks in that case. Yeah. So here the students are proposing this kind of mixed between neural networks that operate mostly in 2D, neural networks that operate in 3D, and so on. Yeah. So I'm just going to move fast through this so that we have time for the Pimlau project. But here I'm just zooming in a way in the entire process. Of course, there are aspects when I'm saying I'm interested in augmentation. Of course, I'm not. That's not absolute in a way, because certain aspects of designs, they have to be automated in order for us to be able to augment. For example, if I want to have this kind of structural information encoded in this kind of agent-based systems, I need to have the structural system automated, and I need to have that structural system giving me real-time information. So for that, in this instance, for example, we started to develop models, AI models that actually learn this kind of idea of topology optimization and then are able to give us predictions like this kind of structural layouts. Yeah. And the same happens here, in this case in 3D. So we always play with this kind of, you need certain 2D networks probably, if you talk about facades, let's say. But if you talk about something else, other kind of design tasks, then you need probably a 3D network. So here, these are two examples then, one 2D network, topology optimization, one 3D network, topology optimization. So like this, you can plug in a way, these kind of networks in different stages of the design. Yeah, so here we are just zooming in again, and you see you have different types of networks and different logics that have to be interconnected, and when and why you need a StyleGAN for this process versus why you need the CycleGAN and so on. If you need a CycleGAN, are you trying to bring in some kind of external information into the mix, or what exactly you are trying to do? If you're using a StyleGAN, are you just trying to learn the representation of data that you already have? So all these kind of questions are very interesting then to address. And in the end, design, it's this kind of process. Design is a series of tasks. It's not necessarily just one big task that you just operate with one network. So here, for example, it's a example of qualifying criteria that the students start to define. And these qualifying criteria, they are very specific to the project. Yeah, what exactly was the concept, the idea of the project, and then they start to develop qualifying criteria according to those ideas and concepts. So we start to develop this kind of models, yeah, that are able to look at this kind of results, and they are able to classify them and give us, in a way, this kind of metrics to be able to sort. Because that's one big problem when it comes to computation in general, and in special the promised way of computation, that we are going to be able to generate variations and variations. Yeah, it's all great that we have variations, but the problem with that is that if I ask you to judge 10 designs against 10 criteria, you'll have a big problem to do that. Yeah, it's very hard, especially if those qualifying criteria are very, in a way, not that obvious. So then we can use networks to help us, in a way, augment our design process and our design our decision making in this design process. Yeah. So here you see that we are just going down this pipeline, you know, almost. And then we reach a level where we start to create 3D networks, 3D objects. And here we have the first StyleGAN network, 3D network that I developed recently, and we tested out with the students in my studio. So here you already see students engaging at the 3D level. So certain aspects, of course, they are relevant to be defined 2D, but other aspects, they are also relevant to be defined 3D. So in this instance, the same, you have this kind of idea of qualifying criteria, trying to look over this kind of massive, you know, a design space and try to evaluate and classify almost design. Because otherwise, yeah, it's kind of impossible. It's just a promise, then just a computational promise without actually being able as humans to perform, to calculate, and to evaluate all the solutions and variations that are created. So here you see the same idea, multiple variations, multiple, in a way, investigations that the student did. Yeah. So of course we end up then with this kind of very intricate, in a way, aesthetics, but that's not the focus here. The focus is this idea of design a process that is augmented by these kind of neural networks. Okay, so now I'm going to go into the Deep Himmelblau project. So Deep Himmelblau project, it's a project that initially I started by myself, and then we started to expand the team. So we have Wolf Briggs. Briggs is really directly involved into the project. Caroline Schmidt-Bauer, which is a design partner in Himmelblau, it's also involved, and also Efilena Bassetta is also involved in the project. So we always look at this kind of aspect of the relation between technology tools and the way that we can augment certain processes, yeah, how we can enhance our decision making, how we can go outside our predefined and preconceived way of seeing things. So Himmelblau, for those of you that do not know the office, they are quite extravagant or quite diverse when it comes to the kind of buildings that they are designing. So I'm pointing to this because their architecture is not very homogeneous in terms of style. Yeah, it's very diverse. I'm going to go over that aspect just in a moment. There are three main aspects in which we are operating with the Deep Himmelblau network. Most of you, if you already are familiar with Deep Himmelblau, most of you are familiar with the Gestalt part, where we are mostly looking at images and how to augment, in a way, designers' abilities. Yeah, but then we start to engage also with aspects of organization. Can we have AIs that are helping us, in a way, figure out layouts and define the organization of a building and so on. And then, of course, technical, which I think technical aspects came first, yeah, and then we start to explore Gestalt, yeah, because technical aspects are optimization logics and all those kind of things. So we always have, in all these phases, we always have this kind of back and forth between automation and augmentation. because certain aspects, like I showed also before, certain aspects, they make sense in a way to be automated, but others, they don't, yeah? Our goal for sure is not to automate design. We are not interested to automate design. We are interested in augmenting design. So initially we started with a very, an example out of the many types of workflows that are in the office is this process where you say, okay, I have a physical model, and then somehow I have to digitize that model. And then once it's digitized, I have to process it 3D, and then go further, yeah, create floor plan sections, run analysis, run renders, and so on, yeah. And then slowly we started to look actually at, can we augment somehow our design processes first, yeah? Can we start to introduce these kind of technologies into the process to help us in a way, in certain cases, speed up things, in other cases, help us take better decisions early on in the design process. And then, of course, the things started to expand more and more and more. And right now it's very, very complex. Yeah, it's even more complex than what you see here on the screen right now. But these are just a few ideas that topics that we start to address. So of course, when it comes to aspects of technical aspects, yeah, of course, we looked very much into rationalizing surfaces and optimization and creating families and clustering and those kind of aspects, which are very relevant, yeah, for this kind of project to keep the budget down. So we have different algorithms right now. I'm just showing you one of those algorithms. We have different algorithms, machine learning mostly algorithms that we deploy for this kind of more technical tasks. And also aspects of environmental analysis in a way, those are really crucial to us also. Initially, you also think about like, are we able to design 10 variations, let's say, and how long is it going to take us to run this kind of analysis in a way, environmental analysis on those models. So we started to look at ways to speed up things. Yeah. So in this instance, this is an example of automation. So we are automating in the end a environmental analysis in a way. Yeah, we are making it real time so that we have a digital model. We have a digital model, and then we have real-time feedback of the environmental impact that the building or the design has. Yeah, so like this, we can model real-time, and real-time have a sort of reaction to that. But then another aspect is it's also this aspect of, okay, but what if you want to have already that kind of information early on when you're just sketching in a way or building this kind of massing models where you're just trying some ideas, yeah? What if you want to have that kind of information there too, yeah? So here we started to look at these aspects also, like, can we bring in a way this kind of environmental analysis early on in the design process? So before there was a digital model, before there was a floor plan section or something, when we just have a study model, can we already have the environmental analysis there? Now, of course, the environmental analysis that you have on a physical model doesn't have to be that precise like the analysis that you have on a digital model, yeah? Because in this case, you're just trying to take or to be inspired vaguely in a way by the direction that you have to take, perhaps, by this analysis. Yeah, it's not meant to constrain you to only like this you can design, but it's mostly meant to help you or give you some extra information to understand perhaps the kind of strategy that you are developing, if it's moving in the right direction or not. Yeah. And then once you put it on a computer, then of course you're going to have a more precise in a way analysis where you also, it matters also certain values, yeah, that you extract from there. So we already have it like almost like a sort of app where you can just look through a phone, you look at a physical model to a phone, and you have this kind of very rough in a way analysis that it's created. Of course, other aspects of automation, they start to be these kind of aspects of rendering, We want to have a very quick render, almost like a base render, and then maybe we can take that base render and apply different kind of networks to create advanced, in a way, renderings. So this is mostly based on ID. So those of you that work with Rhino and Lumion and other rendering engines, you know, you have this kind of ID maps, material ID maps that they have this kind of colors. Yeah. So in our case, we have our digital models. They have this kind of layers with certain colors. So like this, we can very fast, in a way, browse through ideas of how this might look, you know, in the end. So the same applies again, you know, to this aspect of, okay, if I have a digital model, just a digital model, can I have suggestions, perhaps, like how that digital model should be designed? And here you have this example, yeah, where you have that building, but then again, the example goes back to physical models, and you're like, can I have an AI that looks at a physical model and already starts to suggest, in a way, this kind of envelopes or something? So this is what you see here. So we have a camera, you point to a model, the physical model, and then real time you have the output of the network. So here the idea again is not about precision, it's about ideation, in a way, giving certain suggestions, ideas that might become, in a way, a direction that you're taking to further develop the project. Yeah. And here there are a few examples, and going even further, because in this case, mostly you see it's everything constrained to almost like this kind of almost like office kind of aesthetic facade. And here we start to actually look at overall office projects, all the projects that we have in the office, and we start, in a way, to say, okay, can we have actually a network that is able to learn the style of the office? And then, in a way, when it looks at this kind of massive models, is it going to be able to give, in a way, certain suggestions? And this is what you see also here in these examples. So here you see just massive model, and then you have almost like this kind of lattice, in a way, that is suggested by the network. So another aspect, I mean, this is another interesting thing, is that once you have this network learning, then you can flip things around and you can discover compositions in this kind of images that we as designers are kind of blinded to. For us, this is an image of a building that has that kind of fluid roof with a glass wall and then some kind of covering for an entrance. Yeah. But for a network, it's not going to understand, in a way, necessarily those concepts, yeah, but it's going to understand the composition. So in this case, what you're doing, you can also limit the perception of the network, what the network is able to see and what is not able to see. In this instance, for example, our network is blinded to perspective. So we have modes, in a way, to switch on and off. Right now, this is perspective, is not a perspective. And why that is important is because when we look at a massing model, and we look top down, let's say, at the massing model, our brain already processes, before we even are aware of that fact, it's already processing that it's looking at something from top down, and that's a building, and that's a volume, and that's that and that, yeah? So it's already like biasing you, in a way, to see things in a certain way. So for us, then, this is almost like, can we almost like break that connection, like to see directly those things? Can we just say, just look strictly only at the composition, nothing else, yeah? And this is what we are trying to do here. Yeah? We are trying to have this kind of networks that are able to, or we are able to go in and say, now you're blinded to this aspect, now you're blinded to this aspect, yeah? Now you're only seeing this particular idea, now you're seeing also this idea. So, of course, this requires a lot of data, and it's fortunate for us that that we are an office of more than 50 years now in practice. So we have a lot of projects. I think we have somewhere around 600, 700 projects. So we have a lot of material to work with, and also we have it, in a way, nicely structured. So the very first, in a way, ideas. Our goal was, at the beginning, probably we started to play with networks that were out there, yeah? But then for us, we have to gain control over the networks, yeah? We have to be the ones that are designing the networks in a way that makes sense for us as an office, the way that we operate in terms of design and so on. Yeah. So here we start to look at different architectures, and we start to see, okay, can we draw inspiration from DCGAN, for example? And here, these are the first iterations of Deep Pimlau that was inspired by a DCGAN. So the results are very, sorry, they are very cloudy in a way, but some architects might say that, you know, these are interesting and they are inspiring and so on. Yeah? But for us, it's not necessarily what we are interested in. Yeah, although there are some interesting accidents and so on, we are not interested in necessarily just accidents. We really want to have our network actually understanding our way of operating, our style and so on. Yeah. So here, yeah, you just have this kind of training of the network, and you see the results are not really that good. Yeah, if probably if you're familiar with some of my work, usually I like to present things in a progression, only because everything that I'm doing is a progression mostly. Yeah, I'm always like looking back and improving something, and looking back and improving and improving and improving. Yeah, it's never just like, you know, just claim that this is a project from start to end. That it's not. Yeah, usually it's an entire process that goes beyond and a lot of steps and tryouts and so on. Yeah. So again, going back to Pimlau as a style. So as a style is not really that homogeneous. So how we know that, if we run this kind of algorithms, machine learning algorithms, to understand in a way the composition of this style and to understand how it maps in a way each types of buildings that we design in relation with each other, we start to see this kind of very scattered in a way, almost like design space that we are operating within. So the idea here is then those buildings, even if they are very far off, they are scattered, those buildings are still representing Pimlau as a style. So you cannot ignore that, yeah? And you cannot have a network that it's biased towards a few buildings that are more similar. Like, for example, you have here in the center a pack of this kind of data points that represent some buildings that are more similar in a way than the ones that you have here. So you don't necessarily want to throw out in a way those examples, yeah? Because the reason why you don't have that kind of building many times that doesn't have anything to do with the style. Many times it's also about it's a client and suddenly a project was amazing as a style or something, but then it didn't go through the project. So it stopped there. And then another project, maybe it's not really that impressive as a style, but everything was fine with the client, so you were able to build that project. Yeah. So just because you have more data for one project doesn't mean that that project is the most important. So how do you treat then all the projects equally in a way? And you don't bias the network to just look at the projects that are mostly represented. So this idea, I think it's also something that the discussion with bias in data, it's the same kind of problem. Yeah. You have certain things that are overrepresented and other things that are underrepresented. And of course, then the network is going to have a strong bias towards something. So here we try to avoid that. Yeah, we are trying to have a network actually learning the style, not learning the style only of one particular building or overpowering one style of one building with the rest. Yeah. So here you see like this kind of ideas of early latest spacewalks, and here the network was already like more mature. But even here, like there is still a lot of progress, and I'm going to briefly go through this kind of progress now. I'm going to speed up a bit because we are already 40 minutes. So
take your time, Daniel.
Okay. So here you have then this kind of stages in a way of learning. And right now you just have epochs. Epochs means in a way the number of times the network was able to see the entire data set. Yeah. So when you say 222, it means that the network was able to see the data set 222 times. Yeah. So we have then this kind of progressions, and slowly, in a way, you see the network starting to pick up more and more. Now, all these like differences in or all these improvements, they have to do also with training for sure, but have to do also with improvements to the network. Yeah. So this one, we are already far away from this GAN model that we started with. And we start to incorporate other ideas of other types of GAN networks that were there when we were working on this. Yeah. And slowly, I mean, you see that the quality starts to improve, yeah? But it has to do, like I was showing also 2 days ago, it has to do with this kind of aspects of how the network is seeing things. Is the network seeing correctly certain features that are relevant in architecture versus others that are not relevant? What kind of information you give? Are you helping that network to learn, or are you just throwing like data, whatever data, and then you just ask for the network to learn? If you do that, it might take you years for the network to figure out things, yeah? So it's a very intentional, many times, a very intentional, carefully crafted in a way data set, and then very carefully crafted in a way filters for the networks that help in a way drive this kind of progress. Yeah. So here, for example, is the same thing. Yeah. So it's not only about 2D. It's like, how can you start to encode some aspects of 3D, even if it's not full 3D, but 2.5D or something? And then lately, we also started to, we have all our buildings or all our designs, we have them rendered, yeah, nicely rendered 360 degrees. And we have all the passes, all the render passes that inform us about geometry properties, yeah? So like that, we can operate certain levels and we can train the network in a certain way to understand correctly our designs, our buildings, yeah. So that's why for me, it's not only, it is never either or, yeah, when it comes to 2D, 3D. So like, yes, it's good to have 3D in architecture, but a lot of things you can learn from 2D. You'll be surprised how much you can learn from 2D and how much the networks are actually learning from 2D. Okay, so here then you have again this kind of progression, but in this case, like you see September 2019 and then October 2019, and you have this kind of big jumps in a way. And usually this happens, yeah, it's just a matter of training and skills, yeah. And this is something that I think I was mentioning to some students, like, be careful with your models that you're training, because if you train models that are good and you keep on training them, you know, in the future you are going to have very good network. While if you're not training them well, it's like in the end you're not going to have progress. Yeah. So here you have this kind of progress that starts to emerge after you put a lot of effort into training correctly and filters and data sets and all those kind of aspects. Yeah, that might be in a way for architects they might sound very technical. But here you start to see more and more the level of detail that the network starts to learn. It's not anymore that kind of fuzzy in a way kind of result. And here we play, of course, we play with a lot of like algorithmic processes, yeah, because yes, networks are learning, and the network then develops something called the latent space, which is an n-dimensional space that represents all the features defined by the data set, yeah. And then how do you explore that kind of n-dimensional space? Yeah, so you have to deploy a lot of algorithmic processes to help you in a way navigate things, yeah. So, and I'm going to explain this just in a moment. So you have then this network that starts to be able to understand and create in a way interesting designs that resemble in some cases Pimlau. So here at this point, it's already we have multiple GANs that we draw inspiration from, yeah. So the Pimlau then draws a lot of inspiration from multiple networks, and some modules we bring them in, some others we completely develop from scratch and so on, yeah. But the problem again is like, how do you explore this? Because like I was showing in the project, the agent-based creative AI, the problem is, yes, it's amazing that we are able to create variations and these huge design spaces, but it's not helping me as a designer, because in the end, it's going to take me forever to sort and select these kind of thousands and thousands of results. Yeah. So then we start to operate or to think about ways of interacting with the network. So because we are an office, of course, there is a lot of a very strong, in a way, need for us to design this network in such a way that other designers from the office that don't have this kind of skills to operate the network, they are able to operate the network. Yeah. So we started to look then at ways how we can, in a way, make this network accessible to a lay, let's say, designer, a designer that doesn't have necessarily a coding experience, yeah, or doesn't have knowledge of neural networks and so on. So we start to have like different approaches. So now I'm going to just show a few snippets of these approaches because it's going to take me too much probably to go in detail in everything. But we have latent space explorer, we have latent space explorations, which are different methods that allows us to explore the space in certain ways, latent space projections, and then latent space queries, yeah? And I'm going to show you what those are. So here what you see, you just see a tiny snippet in a way, or snapshot of the latent space of the network. In this case, there are 100,000 images, yeah, generated from the latent space. So the idea is to generate this kind of vast, in a way, a latent space, or to output the latent space from the network to output it as an image, and then have designers, in a way, interacting directly on their computers with this space, yeah? So like this could be used probably for ideation. Could be like, okay, let's try to figure out certain things. Let's try to see what kind of designs are possible in this kind of cluster or so on. So here we have then all those kind of methods. What you saw there was you have a UMAP, in a way, algorithm that allows, in a way, to cluster and group and sort these kind of images. The ones that are very similar to each other feature-wise are grouped together, and the ones that are dissimilar, they're going to be placed further apart. Yeah. So like this, a designer can easily engage with the latent space. Of course, it's a freeze, let's say, a latent space of the network, but they can engage without necessarily having prior coding knowledge. And of course, you have then kind of clusters that are created, yeah? And you have specific, in a way, features that are defined in certain clusters, yeah? And once you start to understand those things, it's very easy then to navigate, because I can easily just look for this kind of concentrations. And maybe if I'm looking for things that are variations of things, then I can easily look at this kind of concentrations. If I try to find something that's a bit more outside, then I can look for parts that are more sparse, yeah? So the same happens also here. You have different results that have different locations, you know, in this limited, in a way, latent space that was plotted out. And then we have this method of latent space explorations, which is a set of algorithmic techniques that we are using to explore the latent space of the network. And here you have this kind of idea of nearest neighbor. So what if I input, or what if after I explore that design space in that manner, like very easy manual manner like this, what if I find a design, but I'm curious to see other variations or other slight variations of that design. Yeah? So in this case, you have, you can say, okay, I want to have very close neighbors, or I want to have very far apart neighbors, in a way. And like this, you see, in a way, a sort of range that it's created, but almost like the root or the seed, it's the image that you, or the seed that you selected, yeah, from the latent space explorer. So this is just a animation then of that. So you go from very close, you know, neighbors to very far apart neighbors, yeah. But you see that somehow, compositional wise, you're still retaining certain ideas from the original seed. Okay, so I'm just going to move on. So here, what you have then, you have this kind of idea of how you're exploring the space, yeah? And here we have a technique where what you're doing is you're saying, I'm going to give you a start image, and you're going to search for the nearest, in a way, image that is similar with the input image. And then you're going to take that image that was generated and find or search for the nearest for that image. And you keep doing that, yeah? nears, 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 nears. And that gives you this kind of nice, in a way, almost like a walk, in a way, through that latent space, yeah. Of course, I'm explaining very simple now. Of course, there is a lot of complexity there, how not to get stuck in a way into things that are just similar, and then you just go back and forth. But that's a different discussion. And of course, then we have also this aspect of maybe as a designer, you have certain ideas that are represented through an image, so different modality, let's say. So now you're going to say, I'm going to take an image and I'm going to project it somehow into the memory, into the latent space of the network. And I'm going to ask that network to give me maybe something in that direction, yeah? So here, usually as humans, we always look at some images and we make this kind of associations. We look at this result and we are like, this looks very close to this project that we have in the office, yeah? But can we do it exactly the other way around, yeah? And of course, it's possible, yeah? So we can project in a way that image in the latent space of the network and ask the network almost like to query or to find some solutions that have a similarity to the input image. And the same goes also here. It's a very intuitive then way of exploring the space that doesn't require necessarily computational knowledge. And the same goes here, yeah. So here you see that the network is actually not that creative as us, not creative, but imaginative in a way. Because when I'm looking at this, or when I'm looking at this, I see a similarity with this image from here, but the network kind of takes it very literal. So that's something that we'll have to play with for sure to improve. Now, another one that we start to look at is, of course, also this aspect of clip, yeah? And this is, again, it's an aspect mostly for querying, and it's mostly because we are an office and we are trying to have the Pimlau engaging with designers, yeah? So in this instance, we are not using clip for generation, yeah? We are using clip to explore our DPMBlau network, yeah? So whatever the network learn, we have to somehow gain access without being necessarily a computer scientist, yeah? So here, what you have then, you have this kind of clip, which is a model developed by OpenAI, and I think this was also presented in the first session of this lecture series. And if you're interested, more examples of clip, you can watch that video for sure. So what we are trying to do here is you're trying to create this kind of relation, or to figure out this kind of relation between text, a description, and an image. Yeah. Our goal here will be, can we have a designer in our office that just types into DPMBlau, just types in a few words, almost like keywords or something, and then the network creates for that designer like a sort of selection, a filtering in a way, and then the designer can go on from there. So now it's very different. The way that we as humans describe certain images is very different from the way that the networks are describing or classifying, actually. So in this case, you have the Cypher 100 network, meaning 100 has 100 classes, and it's in a way identifying very interesting, in a way, classes like aquarium and so on. But as you can see, DPMBlau, like, it's still recognizing it as DPMBlau in many instances. And you see that it's quite high. So we are looking at the probability in a way, if it's able to recognize correctly certain things. But of course, this is mostly just classification. So maybe it's not really helping us that much. Maybe it's helping us just to filter things, yeah? But is it able to actually understand the semantics of the text that it's input there? So this is where we connect and DPMBlau with clip. So here, what you have is it's called this kind of cosine, in a way, similarity, like almost like the distance between the text and the features of the image. Yeah? So each, in a way, image in this case gets a score. Yeah, how well is described, or how similar, yeah, how closer they are, yeah, the text versus the actual image. Yeah, and here you can see a irregular shape office tower has 0.29, which is pretty high because we just work with a range of 0.130. So it's pretty high. So it's really, and if we look at it as designers, it's actually kind of irregular shaped office tower, and office probably because it's a glass facade and so on. Yeah. So then we can easily then perhaps have this kind of method of classifying, sorting, having our designers somehow just type in certain tags that they, or certain ideas that they are looking for, and have those ideas extracted from the Pimlau, in a way, latent space. Yeah. And of course, then what we can do here, we can start to sort things and say we are interested to see the designs that are the 5 or the 10 most close designs for this sentence, for example. Yeah. And we can create then classes and say, okay, this is a topology with this facade, for example. Yeah. And then I can say, I'm changing the typology of the building and I'll keep the same facade. So I can have this kind of mixture between different levels of information that I'm interested to explore. Yeah. So here, the same. So you almost like always have this as the topology of the building. So this is a hotel complex that has panelization. Yeah. Hotel complex with irregular glass. Yeah. And so on. Yeah. Or tower with irregular glass and so on. Or tower with triangulation. So you have then always a sort of logic to the sentence, and then you can easily, in a way, create and understand or say, okay, I'm interested in towers, but I'm interested in towers that have glass facade. I'm interested in towers that have panelization. I'm interested in towers that have the structure apparent. I'm interested in towers that have other kind of feature. Yeah. So then you just say, okay, towers, and then I just specify the features that I'm interested in. So then you have this kind of array then that is generated. Yeah. So these are going to be the last images that I wanted to show, and my apologies for running so late. Okay, so this is the last image. Thank you, everyone. Thank you for your questions.
Daniel, don't apologize. That was a real treat. That was absolutely amazing. Before we move on, I just wanted to ask you one quick question what's on my mind. How long has this Deep Himmelblau project been going on? It's about 2 years now or more, maybe?
Beginning 2017, something like that.
Oof, there we go.
And
Clip has come in just in the last few weeks?
Well, a Clip came like, I think 1-2 months ago, something like that. So we started to introduce that there.
Yeah, and that was a real treat to get that in-depth explanation, because fantastic. Thank you so much. Let's move on to Emanuel. That's a kind of tough one to follow, Emanuel. But I mean, you if anyone can do that. Emanuel, who's as I mentioned before, was one of the pioneers in the sense that he undertook a PhD in machine learning in Switzerland. So welcome, Emanuel. Emanuel's now in Singapore.
Yeah. Let me share my screen first. Sorry. Right. You can see my screen now.
Yes.
Yeah. Right. So thanks, Neil, for the invitation to present some of my recent work in AI and architecture design. So today's project will include the ones that I'm currently working at the Artificial Architecture Lab at SUTD, and also some of the work from my teaching over there. I also include some projects from previously from the AA, visiting school, and the EPFL, where I did my PhD. Majority of the work for the first half of the presentation will be mainly about generating 3D forms with AI. The main project, in fact, would be about this recent AI sampling Singapore project. So I've mostly been experimenting on two main forms of sampling. So on the left, acquired sampling continuous space, and on the right, the sampling of discrete sequence. The left one is probably most familiar. Examples include GANs and variational autoencoders, VAEs. This is a simplified version of GAN, for instance, for ease of understanding. The other one, which is probably less familiar for most people, this sampling in discrete sequence. So examples of deep models would be pixel RNNs, WaveNet, and this one is kind of a simplified version of the pixel CNNs. So there are key differences between these two. So the one on the left, continuous space, it is, yes, continuous, but also the learning is implicit. So it doesn't actually, the model doesn't actually see the real data set. And it's latent, meaning what it has learned is represented in the continuous latent space. And inference is really fast. You basically produce the whole, if it's an image, for instance, you just generate the whole image at one go. Whereas on the right, which I'll show some examples in the presentation, is explicit, meaning is looking at the raw input of the images or 3D models, and then it's non-latent in the sense that it doesn't actually have this space for latent exploration, because what it's doing is probabilistic. It's doing like, one pixel at a time, one voxel at a time, and therefore it is very, very slow. So I'll talk about both approaches today. Well, actually, this is the other one that I recently did for. It's more like for the StyleGAN's explanation for another publication for SUTD. Should be out end of this year. Slightly more complicated, but diagrammatically, it builds on top of the GAN illustration you saw just now. So before speaking about this idea of architecture sampling, something that is been looking at during my doctorate studies at EPFL in Switzerland, this overarching design theory, if I could call it, I've tried to highlight three key architecture concepts that pretty much underpin one of the ways in which I intuitively approach the use of AI. Even though I'm not speaking of them at length because it's probably a separate session, you should be able to see these concepts implicitly appearing in the projects that follow. So for those who are interested, I'm currently working on writing a book chapter about AI plasticity, and it should be published sometime in 2022. But very briefly, some of the ideas that I draw from, for instance, would be Mondrian neoplasticism from 1917, or even the Towards Plastic Architecture of 1924 by Theo van Dasbert. This idea of against frontalism, and the idea of elementarism. But more importantly, from a philosophical thinking, is the work of Catherine Malabou, who defines, her works is kind of a French philosopher. Her works is kind of a combination, drawing ideas from neuroscience, neuroplasticity, and so she defined plasticity as the capacity to give, receive, and obliterate form. Thus, plasticity comprises both a constructive, formative capacity, as is seen, say, in the case of plastic arts, in sculptures that takes and maintain a given form. But more importantly for her is this idea of destructive capacity. Of course, she's referencing the French word that then means exploding and bombing, literally. And I actually see this idea of destructive capacity or even destructive creativity as akin to the kind of a mode collapse in GANs, for those who are familiar with GANs, where it kind of never really want to diverge to create diversity. And it's also the idea that form need not be necessarily evolving positively towards the fittest, the ideal. Just like the parallel that she draws from neuroplasticity of the brain, where the brain kind of reconstruct itself, not necessarily to the best and the fittest, but for difference. And in a way, I see it more like a critique on form finding, that currently, at least within architecture, is about this idea of structural optimization towards, or even material minimization towards a ideal fittest form. And lastly is this notion of the identity of form could itself be unstable. One example that she talk about is this, the very fact that the brain structure could adjust and change and adapt itself. It also suggests that the identity of the person can be unstable, or in fact is unstable. So a chair, for instance, a building, or the way I interpret it at least, in the case, say, a form of a chair, a form of building could in fact morph into each other, changing their ontological identity. So in my work, you see often I combine seemingly kind of scale, different objects. Typically the idea of different scale or function. And lastly, I'm also pretty much influenced by Superstudio idea of the histogram of architecture, the project from 1969, which I'll actually speak a bit more. So what is sampling might be easier to just kind of clarify the basis of my inquiry. This idea of sampling architecture, personally, I think it is a question that has implication on how we might perceive, encode, generate, decode architectural forms. Very formal way of saying this, using machine learning and deep learning. So unlike the picture on the left, the classic sketchpad is, I think, is closer to, but not really, but at least closer to the Fairlight CMI, which is essentially a synthesizer, a sampler, and a sequencer. As we can see this, I'm alluding to this idea from drawing to sampling, this aesthetics of sampling. I begin to kind of more thoroughly think about this issue back in 2019 in the Discrete publication edited by Jules Retzin, of which I call it discrete sampling. This idea of the machine seeing things quite differently, and how do we then reconcile, or in fact deal with this new tool. So a standard example would be, in this case, I've redrawn the Stan Allen 1997 figure ground diagram called the field vectors. Typically, as architects in the Gestalt way of thinking, is that this is figure and this is ground. And then we actually just count them. This is what we see usually. But in fact, even from the way of the convolutional way of thinking about this, seeing about this thing is actually closer to this, right? It's statistical. So those who are familiar with CNN, for instance, we know that it actually scans through an image and grab patterns that doesn't really necessarily understand this kind of a complete picture of a figure or ground. So in this case, the same 28 unique equally sized parts, figure, parts, ground patterns with different frequencies. In other words, the picture could be understood as a matrix with samples drawn from some probability distribution of a discrete set. Arguably, so in that sense, arguably, this shift towards sampling could, in a way, found in, as I mentioned, the histogram of architecture by Superstudio, where it's essentially a small sample, a small catalog of voxel-looking light forms. You could actually call it, in a way, training set. Of course, clearly they did not use machine learning, but the idea that there is this abstract catalog on which one could then derive new design was already there back then. So they have actually used it in ways that are across scale. So the continuous monument, the furnitures and products, this kind of easy shift of an object identity. This is the poster I find quite interesting. It was actually exhibited in Lausanne in Switzerland in 1969. So earlier on during my analysis, I was trying to somehow rationalize and machine learn these histograms as numerical matrices. I mean, it's actually quite straightforward because they're inherently kind of a 2.5D representation. And in fact, I was really inspired by their seemingly prophetic words. So I quote here. For them, the problem was to step further and further away with these activities of design, adopting perhaps the theory of the least effort amidst a generalized reductive process. Generalized process is interesting because essentially deep models are trying to generalize based on the data sets they have. And they talk about this idea where furnitures, environment, architecture, meaning anything indeed, could then be effortlessly generated from the histogram catalog. And of course, they prompted about the death of the architect, the architect's tomb, being the histogram. In fact, histogram itself as a word is a statistical word that talks about this binning of, so you have a range of, you have say inputs with numbers, you bin them based on a certain range. And that is, in graphics, you often also talk about histogram to somehow measure the distribution of color pixels, the values of the pixels. And the 3D GAN interpolation, like you saw just on the previous 3 slides, actually served as the basis for one of my entry for the new RIPS, which was exhibited in 2020. This chair, this idea that the chair is familiar, but clearly not the kind of chair that we usually think about when we sort of say, the Autodesk generative design, where we say we want to minimize materials, we want to maximize structure, optimize structural strength. It's something different. In that sense, to me, is kind of a subversion of this critique of such this increasingly mainstream form finding. I mean, nothing wrong with the paradigm, but I just thought that it shouldn't probably be the only way to go. So a follow-up with that idea, in this case, more specifically, more geometrically in a more geometrically specified manner. It is a series of 3D prints from the actual 3D latent walk between a chair and the building. So the top left and the chairs are actually on the left and the building on the right. This cross-scalar notion and the kind of articulation of the 3D GAN generated models could then be further articulated from low res to high res. So in this case, this is a kind of one possible interpretation. So let's start with the sampling continuous space, which actually is reflected in the previous project, the chair. This entry for the Venice Architecture Biennale under the City X Venice Virtual Pavilion. So it's called the AI Sampling Singapore. Essentially, the brief description of the project is something like this. Using 3D generative neural networks, this project actually attempts to sample all high-rise public housing buildings in the entire city-state of Singapore, to then speculate on the possible everyday Singapore architecture. Those who are familiar with the built environment in Singapore, we know that the majority of the buildings are actually public housing, and they look quite similar, as if it has to do with the ways in which the government provide housing for the masses. But then the idea is generate a new architecture that is simultaneously in every architecture. So this is Singapore. This is also Singapore. You see, these are the public housing that we are looking at. Pretty generic, homogeneous. In fact, the project is part of the research project at SUTD. The idea is also to gain some sort of insights into the morphology of public housing in Singapore. But of course, in this case, taking on a generative slant to this research question. In terms of the data set, the red dots actually represent the spatial distribution of the building sample for the deep generative adversarial network. So a quick video to show the process of representation learning and also visualization of some of the architectural forms. there isn't audio, so yeah. So in this case, it's trying to demonstrate the extracting as a start to understand the diversity of all the buildings similarities. This is Disney, not UMAT, which is, I think, UMAT. Danny was talking about that just now. The idea that we could then have that way to measure diversity. Here's a snapshot of a public housing data set. Well, of course, in this case, deliberately stylized in a Superstudio way of as voxels here. Yeah. So this is done much earlier, last year. I will show you the later version. So here we could see that the interpolation with the 3D GAN latent space at this point in time, we're looking at 32 by 32 by 32. The latest version is 64 by 64 by 64. And we're kind of increasing the resolution in the lab. So it's this idea that interpolation between different, several possible high-rise buildings. So we could see buildings that are not too, this model is reasonably well-trained in the sense that it doesn't return you like big, thick, fat building where it's clearly not workable as a massing already itself. Presumably every single white voxel is mass, right? On the right, actually, you were looking at the underlying changing probability of each building voxels in a sense that if it's confident whether that voxel should appear. And to look at different models, like when we train, we train a few, I mean, those who have done training of the deep models, you could train and then compare different models. In this case, this is where the mode collapse kind of being suggested in the second model on the right, where it's slow evolving and it seems kind of stagnant in its walk. In a way, again, alluding to Catherine Malabou's notion of destructive plasticity. So if we compare, just looking at the probabilities alone, we see that the one on the right is very not confident because most of the voxels are pretty much light gray in the color. And so in this case, the darker voxels are the stronger, more probable one, and therefore more legitimate to occupy that voxel space as a legitimate form. You could see the, I mean, not that I'm kind of fast forward for the left latent space, it's just the very fact that the one on the right is really that slow. But it's also interesting because we see that the mod on the right actually show some interiority of unexpected spatial voxel distribution. So the previous latent work was done last year. So subsequently, it became increasingly important to include not only the massing, but also the interior of the 3D, meaning the semantics. Semantic in the sense of we don't see these as just white voxels, but actually colored with a specific function to these forms. So you were seeing a bit. These are actually the samples, and the numbers at the bottom, they represent the latitude and longitude. So instead of sampling homogeneous massing like these that was shown previously, the idea is to do this. Well, actually, it's already been done. It's to kind of, in this case, the red color represent the public spaces, the ground void decks, which is quite common in Singapore in public housing, and also the sky garden, which also in itself increasingly more common. And the common corridor, meaning the connection between different apartments on different levels. And the green part represent essentially the apartments, the main body of the form. And the blue voxels represent the vertical circulation, meaning going up different floors, and also the roof surfaces at the very top. Therefore, you always see this kind of blue voxels all the way to the top. If we were to cut a section through these massing, we will in fact get the interior color distribution as well. So this is kind of an extension of the previous idea, and so if we think about it in kind of a voxel space in higher res, as I mentioned previously, this is how it will look like, and this is what the inputs for the 3D GAN model will in fact look like. But in this case, with the semantic encoded, so it's also learning the semantics, not just the form. A close-up of the data set. So here we see that the interpolation through that latent space. So every voxel now has a color that is linked. So the green apartment pretty much, maybe I should just run again. The green apartment typically from the main massing of the building, the blue vertical cores are pretty consistently generated. And even at times when you see kind of a slab block, you see them appearing on reasonable interval just to gain access to the vertical core of a high-rise building if it's a slab block. The blue roof again is always there. The red common corridors, we could see that is sometimes the red also represent this sky garden. So increasingly there are more sky garden at mid-level of high-rise building. So fine. The model managed to learn something. How to generate a potentially workable building, including all the necessary function, circulation, distribution of the apartments, and this is just kind of the still frame of the interpolation from the top to the bottom. Some snapshot of the training. So this is the one of them. We see that it is in the beginning it's pretty messy, right? You get almost broccoli looking like forms, towers with nose mainly green, and the blue part is still pretty much up there. And another example where we kind of sometimes get teapot looking like objects along the second row. But still the blue part is pretty much the semantics of the blue color. That one been picked up quite early on. We see some interesting kind of even cantilever on the left left column middle row here, for instance. Of course, there are instances where you have floating voxels that doesn't make sense at all. Another one here we also see. So in a way, you can imagine these are actually closer to the kind of MRI thing where this is not just an envelope. If you cut a section through all of them, you actually see colors in there, telling us where are the corridors in that big massing. Just I'm not showing here. So in the beginning, we learned about form, initially inspired by the Superstudio histogram architecture. And then the idea is then here, in this case, the semantic transfer, which actually we have a model to do this semantic segmentation even, but up to a certain resolution. And then the next step is this question of resolution, right? Which is the architecture transfer. This is where the discrete part comes in service of the continuous generation of the form, where every voxel draws information from not just the semantics, but also the probability of each of them. So this is early stage. So the exhibition, in fact, for those who are interested, you could look at the video on the I think it's the 12th virtual pavilion at the Venice Biennale exhibition. New information and new progress will be updated actually. Now let's move on to the discrete sequence, which is quite different. So the discrete sequence is closer to, this is a recent experiments that I've been working on. So if we don't think about discrete as discrete voxels, if we think about discrete as vertices, discrete as in per vertex, per face, what does it mean? So unlike the GAN, the continuous way of thinking is to kind of represent it in a way that is actually not in a raw sense of the word. Raw sense meaning the raw geometry, the points, the lines, the faces, right? So this one that I'm currently working on is using transformer encoder and decoder, based on kind of an autoregressive way of sampling. And here this example of the one of those public housing buildings that you saw just now, but kind of thrown into this model instead, where here it seems as if you get the whole building at every frame, but actually it's not. Actually, in each frame is sampling one vertex at a time, and one vertex at a time. And so once it's finished, it has finished generating the vertices, then we use the chain rule in probability, right, where the faces are conditioned by the distribution of the vertices. So then we sample the face one at a time. So vertices, and then condition the faces, the faces generation based on the vertex distribution, and then we generate the form. Therefore, you should see that the black points actually settle really fast compared to the faces, because it's a bit complicated to figure out which points to connect to create a face. Yeah, in theory, it could be, well, in this case, it managed to converge quite reasonably. Of course, there are many glitches along the way. I mean, at this point in time, it's not possible to figure out how to do the texture. Yeah, so these are some examples of messed up. So to better illustrate this second form of sampling, and also in view of the time that we have, I thought I might want to quickly revisit a few older projects that also learn by sampling in sequence. The first project was actually related to Theo van Dasper's this idea of elementarism, which is again part of the neoplasticism of Fitzmondrian on the left, and then the input being the Dessau-Bauhaus, the Watergroupes Dessau-Bauhaus of 1926. So some of you probably seen this project before. The original Dessau-Bauhaus in the middle, and through a process of sequence sampling, one could then generate a family of them. So if we throw in the same thing into the HDB that you saw just now, of course, this is actually easier because the phase count is less computationally heavy. In fact, in terms of memory, the discrete sequence way of doing is actually quite heavy in because that's why it's also slow. So you could see that just now it kind of well, it's not exactly perfectly correct, but reasonably correct. So this other project, I thought it's quite fun to show this project because it actually informed the ways in which I have thought about the AI sampling Singapore semantics. This is actually, I was inspired by the discrete aesthetics and the sequential process of the archisms. We know that the left image is, I mean, the archism people, they actually did it on the typewriter, right? Sequence, discrete types, right? So in the case of the Pokemon, for instance, we have the discrete tiles, and then we generate, right, sequentially. So from top left and to bottom right, and just keep on going. Of course, we see some issue. This is actually kind of linked to the other projects, the Miss Van der Rohe also, Miss Van der Rohe project, the discreteness. But essentially, actually, the paper is somewhere published in 2018, I think. You can have a look. There are some distribution, but and also in theory, like just like the no stop city, you could generate endlessly in sequence. So the originally the experiment was done in kind of a black and white and no semantics, but it becomes necessary to then, of course, there are more tiles in the encoding, so the trans character was actually used also is more fun, looks cool, and this further analysis mainly on kind of black and white, and then subsequently in color. So the blue part represent the water bodies, the orange part represent the building. So quite similar to the HDB, but of course a very different a model, a very different machine learning model. This other project, which is the Discrete means, the Barcelona Pavilion. Again, the idea, also the no-stop city of Barcelona Pavilion variants, the model actually learns some similarities. So when I talk about this idea of resolution, is also how to then sample, because we could sample and then quantize, meaning binning into the histogram as a histogram. Is this how do we split a model, right? So unlike the vertex and the phase way of working, which is the more recent one, this old project actually split up a building at different resolution, and then sample them, creating some kind of a hierarchical understanding of a given form. So if we compare it at scale, this is how they look like. I mean, the original one, the original tiling of the pavilion, Barcelona Pavilion, is actually 1 by 1. So what if we have done differently at different resolution? Just going more quickly. So if we have just sample like randomly uniform probability distribution, this is what we get. We just get nonsense. We do see the bench appearing somewhere there in the walls, but essentially nonsense. And if we also then just generate based on the frequency count, meaning no learning, just based on like a word cloud. If you see this more often, then generate this more often. We get something like this, fine, still quite nonsensical. But when we start to learn in sequence, in this case, prioritizing a specific directionality of the sequence of the in the input, then we could generate something. In this case, with a very specific bias towards the horizontal, and in this case, a specific biasness towards the vertical, meaning the other direction orientation. And of course, if we enlarge the recent project actually learn the entire sequence of the previous vertices. But in this case, there is a limit to what is being learned. So if we, in fact, control that, we could control the degree of learning and forgetting, and therefore generating rather different looking, but yet similar looking designs. In this case, it still sends a bit of a Mies van der Rohe thing, and some examples from, well, if we change the parameters, the hyperparameters. So in this case, the middle is the Mies van der Rohe, and it's surrounded by other ones with different degrees of similarity. This is another, which I'll go just 2 slides for this one. It's about the same idea, just sample at a different kind of resolution, producing different fidelity to the original design. So the Ricardo Bofius, La Morala, Roja, kind of split A and B, just taking the staircases, the zigzag staircase and the spiral staircase, and closed spiral staircase, and but then combining the probability of what's been learned from 2 different models, we could actually do some combinatorial generation. So if at the bottom is the one that is where we combine, we see some instances. So the different columns over here represent a lower res way of sampling this. So the resolution will just go higher. But of course, when it goes high, it gets a bit more predictable. If it gets lower, it gets a bit more messy. So the kind of a middle ground is often more workable. This other project that is kind of, again, a kind of thought experiment about this relationship of looking at the Maison Domino and have a counter version of it called Maison Domino B, which is basically the anti 5 points of architecture, right? No free facade, no pilots, and so this idea. So then we come back to this resolution and convolution of an object in 3D space, and then so this is at 1 resolution. This is like a 5 by 5 by 5. Of course, it increased exponentially because it's in 3D. So yeah, so in this case, there are about 3,000. Again, doing the combination a bit messy at this resolution as well, but we see features. We could also do kind of a divide, kind of minus. So unlike the GAN where you use the vectors, the arithmetic, so you class, you're probably familiar with a face of a man and a face of a man without glasses, and you minus off, you could do this kind of plus minus thing, but in the discrete sequence is we plus minus, because we don't have a latent space, we can't actually do that. We can only do that by mixing the distribution of probability. So again, these are some other version, just learning on its own, domino A or domino B alone. Yeah. Okay, other stuff. So actually, much earlier on, when I first got into this deep learning, was actually my first experiment was back in 2016 when I was experimenting with students with the 2D neural style transfer. Back then, it was really not easy because setting up, we didn't even have like a Colab, and installations just kind of kills the student off like immediately. So, but we managed to do something about style transfers of different parts of the city in Shanghai, Pudong and Puxi, and also looking at different buildings where you could combine them. So rather than seeing style transfer as texture plus the content, what if we see them as the same thing? And what do we get? Of course, back then we actually get a bit of a nonsense here. And then subsequently, then the following year, I was looking at the semantics. So again, bringing back the semantics back to give a bit more control as constraints. So in this case, a combination of some city blocks in Shanghai and also, in Beijing, and also in Manhattan. And then subsequently, this is also based on a sequence modeling. Some of the really old style transfer, yeah, pretty bad. So yeah. And then the one where the semantic came in to 2017. So we could actually learn it's essentially like pix to pix, but it's not again. That was 2017. It's actually called neural semantic style transfer, but not in the GAN way. It's based on here the video shows the process of optimizing the hidden layers. Here we're basically learning the Barcelona city texture. Even earlier, also in 2017, that was beginning of this kind of interest in machine learning, but here we are looking at the eigen decomposition. So you could think about, you can get a latent space in a way without actually doing GAN. You can do it with eigenvectors and eigen decomposition. So in this case, it's just showing, this is like 2017, showing kind of how to morph between buildings by taking the principal components of what's being learned in the process. So this is kind of 2.5D. So, but we could see this combination happening. And subsequently, of course, in this case, this is at this point in time is doing its own exploration. So it's just kind of going on its own. Imagine it's moving in that latent space like randomly. And the 3D, this experiment that I also did back then as a kind of extension of this floor plan is learning in 3D. Also, again, my interest in the voxel space, also interpolating. But in this case, the forms are pretty much abstract, so it's difficult.
So we're running out of time. Could we possibly?
Oh, sorry.
Yeah. No,
sorry.
Yeah. Okay. I mean, just maybe we can come back to this at the end. That's wanted to. There's a few things I'd like to just quickly. Could you maybe unshare your screen a second?
Yeah, sure.
That's. I mean,
sorry.
No, that's okay. That's okay. It's just that. Yeah. No, it's.
So sorry.
I want to just quickly shift, because I want to bring Benaz in a moment, and they've taken a very different sort of view on things. And it was actually great to see that some of that early work, because I think, you know, what to my mind is really interesting is the fact that you and Daniel, and also Casey Ream, whose work I'm showing here, were kind of working at this kind of this area in 2016 before it became trendy. I mean, to my mind, 2019 was when it really took off, and yet there was some experimentation going on. And this is the automatic Ginza that Casey was involved in, and some explorations of 3D work that I think is really kind of like pushing things and opening up things in a new way. Casey's been working at this, I guess, from roughly the sort of same time. But what I wanted to try and bring in here is something actually very, very different, which is to say, you know, I think what has been is interesting is the way that AI has been used generatively to kind of produce all this new stuff and approach things in a completely sort of new way, and to see the evolution of your work, I think, Manuel, and also to see the evolution of Deep Pimlau. It's a long-standing project, and it's you know, there's an incredible amount of investment in it. But alongside that, there's a kind of, what I would say is there's kind of creative use of applications of AI that have been going on. In other words, you know, almost like when we first saw the use of robotic fabrication and computational design, the first question was, how do you do it in the first place? You know, and then the second question became, well, how do you then imaginatively deploy some of these techniques? So it's not just simply a question of kind of fetishizing the fabrication processes, but what do you do in terms of the exquisite products you can produce? And this is, in a sense, from a kind of an AI point of view, is taking things in a kind of completely different direction. In a sense, it's kind of like, it's not just simply AI. It's kind of like these are AI-driven characters, but it's using a gaming platform, and it's opening up the possibility of how we can just inventively deploy this to open up new creative modes of expression. This is a new Campomarcio project, which is done by a whole team actually at SciArc. That's not just Casey, but also Laura Michelin and Damian Jovanovic and Lydia Kilarovic, who are kind of like reinterpreting. It's an open-ended zero-player simulation game powered by AI, and based on Piranesi's famous drawing of the Campomarcio, where here they're using a neural network to learn the features out of the original drawing and then generate a 3D version of kind of infinite versions, shall we say, of Campomarcio. And then these spaces, these new worlds they're kind of generating, become the kind of populated by these autonomous agents that are the new residents of the Campomarcio, as it were, AI-driven creatures and so on. So that, in my mind, is one of the things. The other one that this is by Damian and Lydia again. What they call the dream estate, which is again with AI-driven characters who are kind of customized in a certain way and navigating a new terrain. And again, to my mind, this is expanding the domain of what we are doing in architecture. It's using Houdini also, an Unreal Engine. So it's not just AI, but nonetheless an inventive way of operating together with these with AI. So it seems to me that what we're also getting alongside the really rigorous kind of exploration of the generative processes, we're getting this kind of inspired kind of combination of AI plus other engines, which are kind of giving us a whole new domain of operations. So the next what I want to do now is to invite Benaz Farahi to show some of her work. One of the interesting kind of questions about AI, one of the challenges about AI, has been from a kind of political perspective, is the way in which it's always been accused of bias. It has bias in it, and there's a whole debate going on about the problematic questions about AI and bias. What I find interesting about Benaz's work is how she also, in a very kind of inventive way, has taken the possibility of how you can use the logic of AI to overcome bias. So I'm going to stop sharing my screen and hand over to Benaz and invite her to show something of a recent project, Can the Subaltern Speak?
Hi, everyone. Thank you, Neil. Before I actually show the last project of mine, I would probably take a few seconds and talk about overall my practice. I have trained as an architect, but I work at the intersection of architecture, fashion, and interactive design. And I have been using a variety of computational techniques for developing a new type of relationship between the human body and the spaces that we occupy, ranging from the scale of wearables all the way to architectural scale. But more importantly, I've been working with a variety of facial and computer vision technologies for tracking various informations from users and develop an intuitive interactions between the body and the space. So with that introduction, I'm going to share my latest project, and there's a video essay that I would like to play, and then I'll be open to any questions you might have. Let me share the sound. Masks have a long history, from Iranian masks protecting women from patriarchal oppression, to masks of North-West Coast Indians, to masks worn as political statements. Masks take on a range of different religious, social, and political roles, and offer an interesting insight into how we use them to either conceal or reveal our identities. This project is inspired by the historical mask worn by the Vandari women from southern Iran. It's been said that these masks were developed during Portuguese colonial rule as a way of protecting the wearer from the gaze of a slave master looking for attractive women. While these Iranian masks cover most of the wearer's face except the eyes, I've been wondering how the eyes could be used as an expressive medium for communication. In my research, I came across an interesting incident in which an American officer used blinking to send a secret message. In this video, you're seeing Admiral Jeremiah Denton blinking the word torture using Morse code during his captivity in Vietnam.
Well, I don't know what is happening. But whatever the position of my government is, I support it fully. Whatever the position of my government is, I believe in it. Yes, sir. I am a member of that government.
The use of code for communication is nothing new, and in fact, women came up with a code word as a method for reporting domestic abuse during this lockdown. I've been wondering how we could create a new language for communication of a secret message between women. In this project, I was particularly inspired by the recent experiment involving 2 AI bots at the Facebook AI lab. The intention was to monitor how 2 bots might develop a dialogue. However, during the experiments, the bots seemingly started to formulate their own language, a language that no human could understand. The researcher had to intervene and tweak the algorithm to prevent this happening. This story could also reveal how knowledge is power, and inability to understand unnerves those who wish to maintain their authority. The design of these 3D printed masks are informed by the Langer line of the human skin. Langer lines are topological lines in the skin which corresponds to the natural orientation of the fiber in the dermis and are perpendicular to the orientation of the muscle fiber underneath. Each mask fabricated using SLS 3D printing technologies and consists of 18 electromagnetic actuators with fake eyelashes
which gives the illusion of 18 blinking eyes looking at the viewer. One of the challenging tasks was to control the behavior of the array of electromagnetic actuators using custom-made electrical boards, which received the signal from the microcontroller and translated to electrical impulses controlling the rotation of each actuator. Technically speaking, the custom-made PCB driver boards control the actuator's position and allow them to independently receive signal 60 times a second, 60 Hz. We also have produced a very small custom-made proximity sensor which is embedded inside the mask above the wearer's eye and track the openness of the wearer's eyelid. This information controls the speed of actuator's movement. On each mask, every 6 actuators are connected to a custom-made PCB electrical board. Total of 3 PCB driver boards, a small microcontroller, a small proximity sensor are all embedded inside the mask. These sentences make little sense. That's because it was not written by a human, but produced by a machine using a Markov chain, a common machine learning algorithm for simulating statistically modeled random processes. Basically, it's a system that transitions between states using probabilities. It's a sequence of states, for instance, the probability of a sunny day after a full day of rain. Note we have states and transition probabilities. We can also use Markov chain to create a text. We trained a Markov chain using the seminal article Can the Subaltern Speak by the feminist theorist Gayatri Spivak. She asked whether it might be possible for the colonized, the subaltern, to have a voice in the face of colonial oppression. We represent each word as a state and view transitions as a likelihood that a specific word might go after another. We can consider these states at either a word or character level. We can analyze what the probability might be of a given letter appearing after 3 letters. For instance, the probability of a space after the. In the field of computational linguistics and probability, this is known as n-gram, which is a continuous sequence of n items from a given text. In this case, our n-gram is 3. The n-gram of a given text provides a strategy for generating the next text. The Markov chain could be therefore used to generate a text where each new letter is dependent upon the previous letters. As the mask communicates using BLE protocol, the algorithm is repeated and the n-gram changes. The smaller the n-gram gets, the less meaning there is in the generated text from a linguistic perspective. Each letter generated through this process is translated into Morse code, which informs the movement of the actuators. In the video documentation of this project, which will be shown shortly, you will see 2 women wear masks covered with eyelashes controlled by a machine learning algorithm. They begin to communicate with each other, blinking their eyelashes in rapid succession using Morse code. The goal is to develop a secret language for transmitting information between multiple women. The project brings together design, critical thinking, feminism, and AI. It's important to point out that developing a new language is extremely challenging for two main reasons. Firstly, AI systems do not have any real understanding of the meaning of the word they use. Secondly, the production of language has a complex set of requirements, including social, cultural, and political contexts. However, this art project speculates that if these women were to continually wear these smart masks instead of their passive masks, one day they might be able to develop a new nonverbal language between themselves using the blinking of their eyelashes. Future iteration of this project could incorporate more control by the wearer over the content of the messages. I foresee that the use of brain-computer interfaces could develop a seamless, intuitive interaction for the production of secret messages. Last but not least, apart from being social and political commentary on ways of subverting patriarchy, this project could also offer insight into how masks could be seen as an opportunity for communication and social interaction. In the light of COVID-19 pandemic, where we have to cover our faces, thereby masking our emotional expressions, it is important to think about how we might be able to express ourselves and communicate more effectively. These systems could also benefit those who suffer from auditory impairment and hearing loss.
Thank you very much.
Thanks, Benaz. That's a extraordinary project. I love that project. And I think is the same Julian who was helping in that project who's going to be with you on your workshop for Digital Futures?
Yes.
Yeah.
We are going to teach a workshop together this year on control of different types of actuators. Particularly, we're going to focus on LEDs, but we have developed the software for controlling irregular formations of actuators. So we'll be teaching it together.
Great. Okay, so I just put a question in the chat saying everyone doesn't mind staying on for a bit longer. Daniel responded saying the night is young, and Emanuel said it's still morning here. So let's keep going for about another 15 minutes or so with some questions. I think the work really deserves it. It was really a really inspirational work, and I'm really grateful for those presentations. Amazing. And I think also it was kind of interesting that the sort of the shift in the second part, the final part, where we're going moving towards the creative use of AI. So not just AI as a generative tool, but also how it can be incorporated, and particularly given a kind of political edge to it, which I thought was really refreshing and different. If you have any questions, please put them in the chat. If you're on YouTube, we can also pick up on your questions there. Maybe I think I could ask Daniel a question. I think in some ways, I mean, I thought what you've been doing, what I love about that project, you've been really working at it for years. It's not just one of these things you do overnight. It's almost a labor of love that's mutated and changed and taken on board. Things like Clip, as they evolve, and of course we're in a ever evolving kind of world in some senses. So I got two questions I wanted to ask. One is that so there's a new kind of process in some ways that is evolving, which is kind of quite productive in its own way. But in some senses, it's different to the original process. If you think about someone like OMA, they have a certain way of operating, and might there be a way of aligning to their standard operations, or do we have to kind of open up in a new way? Because I guess my thinking is I first came across computation years ago, like when I was working on Alberti, and I in those days I was in the main computer science department of the University of Cambridge, above the Charles Babbage lecture hall. And I was surrounded by these geeks. And the thing that came across to me was what computation could do was allow you to play with language and refine things. It was about the process. At the time we're in the age of postmodernism, right? Late 80s. And my supervisor said, what style are we going to use? But there was no style. What came out was something came out of the process itself. So I'm just wondering, in a sense, once you're working with the finished product of previous designs, is there a way that one could maybe think of how the standard process of whoever a particular practice might approach a design, whether that could be thought through the logic of AI, or do we need a different process?
I don't know. I think something similar happened also with parametric design. I think architects started to have a completely different way of operating just because of parametric design or different kind of technologies that we start to engage with. And that should not be reflected necessarily in style. Once you see in a way, you see the stylistic part too much stress, probably you say, okay, probably they don't have control over the process, and that's why they talk so much about style maybe. But I think it's mostly about process, and I think it's going to really help us understand certain things in the design process that right now we are not aware of because we are not forced to think that way. Because parametric design, puts a sort of frame on the way that we think about things, especially if you design these days, So even if you are not saying that I'm designing parametric architecture, let's say, but once you start to engage with that tool has a language, a way of operating, and you have to formulate your concept in a way so that they fit in a way, that kind of way of operating, and that has an influence, has an influence on the way that you design for sure. And here is the same thing, it's going to be the same. Now it's going to be something that is going to allow us in a way to be even more vague, because parametric design requires you to be very specific in a way. Like it's very explicit in a way as a command. You have to really say exactly what you're trying to do. But in the case of AI, it could be that, we don't know. You just have a rough idea, and maybe you just say, okay, I need AI to fill up the blanks. Maybe I want something, and I don't know exactly what it is. I show it to an AI, and maybe that AI is going to help me figure out something, and then I go from there on. And is that going to change things so that we are more vague, the way that we are describing things? Perhaps, I don't know. But I think that we'll have to also deal with availability of networks to be able to engage like that, which right now I don't think we have. You're muted.
Sorry, I was sat quiet. No, what you're suggesting is that in a way you're kind of picking up on what Emanuel was saying in terms of Catherine Malabou's idea of the plastic mind. We will adapt to the new tool, and we will find new ways of operating. That makes complete sense. I think in some ways already we're finding, and almost we have to find new vocabulary for what's happening, because once you're working computationally, you're creating a search space and unleashing an algorithm and so on, you're getting outputs, then you evaluate, very, very different. So we've already mutated and changed in some ways. I just wanted to put maybe a question based on that to Emanuel. So I'm just wondering, because the body actually, the body mutates in two different ways. The mind, and this is the kind of the thesis of Andy Clark, really. We're natural born cyborgs. We adapt to these tools in a way, and it's because of the plasticity of the mind. But the other aspect of plasticity is the way in which the body itself is kind of plastic. Darcy Thompson, for example, looks at the way that, let's say, you take a cross section through a bone, and you can see the structure of the bone itself, which actually is, and I'm no expert on this, but I understand that the bone is continually mutating and changing and responding to the the stresses that it's put under. So somebody, I don't know, playing golf has got a different kind of bone to someone playing American football and so on. So I'm just wondering whether that might be a model to take on board, because I mean, Catherine Malibu is really about the mind, whereas if you think about the way that kind of, as you mutate and change the kind of structural operations, that seems to me closer to the architectural form. Would that make sense?
Yeah, thanks, Neil. The reason I brought the quoting Malibu, I think because it seems to be an alternative way to think about form, because we know even way back, this Darcy Thompson, this way of thinking about form, the idea of evolution. Even Schumacher is still talking about this idea that the underlying logic is evolutionary, but what she's saying is that this is not necessarily the case, so the example of the bone that you're saying is actually usually mutating towards a better version, ideally. But she's saying something different. She's talking about this destructive aspect of it, which relates to how when people get certain parts of their brain damaged, they morph into someone else altogether, which is so radical. Right, examples where people suffer from brain damage and that they no longer could recognize you. It's this change of identity. Whereas the analogy of this bone structure thing you're talking about, there's no way to go beyond a bone. It's just still a bone, essentially, right? And the way she links to this in research in neuroscience and neuroplasticism of research, I find quite new. I mean, she's been talking about it for like 2008 or even before that, but quite relevant and timely, I thought.
We got a question from the chat. First of all, we had a lot of comments. Someone called Akshay Kumar, I guess that must be from India, said just beautiful. And other comments like, this is amazing, really amazing work. So I think you guys have produced you've really made people stay. But there's a question from Zilong Tang. He or she says, all our amazing works, thanks for sharing. I know probably the use of AI in the AEC industry is still in an early stage, but has any of you utilized AI for a real architecture project in any form?
Yeah, so in our case in Pimlau, we already used AI, but AI not as in neural networks, but AI as in machine learning algorithms. We use a lot of those kind of algorithms for optimizations. So optimization when it comes to rationalizing surfaces, then creating families of panels and all those kind of topics in a way that are very, very pragmatic, have little to do with design, let's say. So mostly, and that project actually, the project that I showed also in my presentation, that project, I think they broke ground like beginning of this year or something like that. So they're already building it.
And I guess I should maybe add that there are structures like Jenny Sabin's Ada project, which has a small amount of AI, but it has facial recognition, things that are making it interactive. So there are kind of aspects of that. But I think it's fairly safe to say that, we'll find out in the next session how this has really been implemented. And it's interesting because we're literally, for my book, I was trying to find illustrations of actual built projects and really, we don't really have anything as yet, but they're on their way. So, Emanuel, do you want to offer some comments on that?
Yeah, so on my side, we have, in my lab, we are working with government agencies. So mainly on predictive stuff, right? So segmentation of facades, building conservation, how do you identify defects or non-compliance of building renovation? Not generative, but they are useful. And so it has its place in, I suppose, digital humanities in the kind of conservation and preservation domain. But at the same time, I have other projects which is about this embodied AI. So it's about, I have colleagues whom I work with robotics. So on our part, it's really about the environment where they do the simulation and how to think the environment as kind of a virtual agent. I think in terms of the AEC, we have actually within a university requests of kind of teaching courses to the industry, and oftentimes it tends towards the automation part of things, which is clearly more directly practical. Yeah, so it's just maybe not exactly the thing that we were kind of showing just now, which is more interested about the experimentation and generative design process.
I've just allowed all the attendees and panelists hopefully to talk if they want to ask some questions. So let's open up. I don't know if anyone wants to raise their hand and ask any questions. I can also make you visible, I think. Yeah, no, I mean, I think that. I mean, maybe this is a question for Daniel. I think, because things have kind of mutated and changed, and you really can't predict what's going to happen because things are. I mean, the speed of change is really remarkable. And I would be caught out with this in my book. I mean, Emanuel's already published a book on these things, and I'm sure his book was out of date already, but mine's certainly going to be out of date. I mean, I literally last week I was having to kind of look at the proofs of my book, and I had to somehow fit something in about Clip because Clip had basically come onto the scene, in the last 2 months or so since I submitted the manuscript. You almost feel like books themselves have got to be like Catherine Malibu's Plastic Mind. They've got to be mutating and changing. I can imagine something like a Google Doc that could be updated or something the whole time. Maybe the way of dealing with it. But the problem is that things are changing so rapidly. One of my students last semester was just announced. I didn't even know at the time because I was that he had a Tesla, and he said, "Oh yeah, I've got my Tesla's now been upgraded to be fully self-driving," and it's the speed of these changes which are really remarkable. But I just want to ask Daniel, how do you see? I mean, it's difficult to predict, of course, in the future, but how do you see that? What's the next step? Do you see in this process?
In the Pimlau project, you mean?
Well, in any project, how do you see what's going to be the kind of next phase transition that's going to really change things?
Well, I think to really have a true transformation, we need to move outside of individual offices in a way working on AI. Somehow AI has to become more available to offices that actually they cannot afford this kind of research project. Yeah, in our case, we have a way to afford that research project, and I think once it starts to get to that level, I think then we start to really talk about a big impact in architecture. Because right now, also our model, even if we have like 50 years of data, back data, regarding like the Pimlau and projects and so on, yeah, it's still limited in a way. It's the Pimlau universe in a way, yeah. But I think we need to move outside of that, yeah, and to have cross in a way breed between different offices. Then I think we start to really talk about interesting things. And for me, that will be the next thing. But I don't imagine it as or I hope it's not going to be something like a big AI that we just subscribe to, and we just have this kind of false impression that we create something new, when in fact we are within that space defined by that big AI. So for me, that will be like if we can reach this kind of level of personal AI in a way, almost, where each one of us, we have this kind of assistant to augment whatever. Could be architecture, could be writing, could be something else. Yeah, I mean, writing, we already have it. But all these other tasks in a way that can help us become even better as humans. Yeah. So for me, that would be, I think, I don't know when that will happen, in 20 years, 10 years, but that will be a major step that actually will start to make a difference. Otherwise, we are talking about very isolated, the same model like the parametric model. Yeah. Because the parametric model is the same, Grasshopper and so on, is the same problem. Like you just have a few companies that are able to afford those kind of technologies, and not technology necessarily, but the specialized workers in a way to engage with those kind of technologies. And then you have a lot of like big part of architecture that actually is not digital probably. Yeah. So I think that should be the focus, because otherwise, if we just focus again on just big offices and just a few isolated examples of AI in architecture, we are going to have the same model, like parametric design model. Yeah. So I mean, that's probably what I think about it.
I guess I'm just wondering, just thinking about other industries, shall we say? I mean, I was kind of shocked when Gmail started telling me how to finish off my emails. that was interesting in itself, and then you have things, Spotify and things, and the fact that now you get targeted by, for the news that you're likely to want and so on. It just strikes me. I know this gets far more complicated once you're working with a kind of three-dimensional discourse, but I can imagine that already there's a kind of profile built up, of what we like, and the possibility therefore of automatically sort of kind of not finishing the sentence but finishing the design seems to me the kind of the kind of obvious step that could happen.
But I think AEC industry, it's very, very messy and very, in a way, intricate and very hard to navigate. And I think there were already like some startups that actually failed. They were promising to revolutionize, in a way, construction industry, and they failed miserably because it's not easy. Yeah? And also when it comes to data and all these kind of aspects, it's very hard, in a way, to have consistent data from multiple offices. Even if you talk about Revit model, it's not always consistent, and it's very, very hard, to sort through that data, to probably manage it and so on. So from that perspective, I mean, yes, it will be great, but I think we have a lot of roadblocks ahead of us that for sure we should, in a way, be optimist about, there's a lot of progress that is being done in AI, but in the same time, we have to be realists and be aware of the obstacles that we have ahead of us. And maybe if we do that, then probably we are going to be more efficient in trying to go over those obstacles. Yeah, but right now, I don't think it's realistic from our side to think about aspects of AI revolutionizing architecture completely in 10 years, 20 years. Maybe we talk about 40 years, 50 years. And this is just based on some experience that I have with AI and some experience that I have with parametric design. Yeah, it's very messy, everything that we have. It's very messy and it's very hard to put things together. And there are multiple systems, yeah. So probably construction industry cannot be changed by top down. Cannot be changed by somebody just picking, in a way, the task and saying, I'm going to solve this issue. No, I think we have to come up with this kind of very local, in a way, solutions, yeah, and try to address those things. Is AI going to be able to give us, in a way, suggestions about something? Well, yes, it might be. And let's say that I can make the claim for the Pimlau. So I can overimpose, in a way, the Pimlau on the world of architecture and share that with other architects. But is that what you want to have? Not necessarily. You want to have something else, yeah? But then how you collect the data in a field that is so not structured, yeah? So I think that's a big challenge. So probably we'll have to partner more with computer science and really have architects that this is what they are doing. They dedicate their life to actually collect and organize proper architectural data. And then probably we can talk about architectural AIs like Spotify or other kind of platforms that, in a way, before I even finish my sentence, that AI knows my preference and knows how to finish, yeah? So I think that's the big challenge. Because even if we talk about modeling, let's say you have Rhino as an engine, it's quite homogeneous in the sense of Emanuel is going to open Rhino, I'm going to open Rhino. The objects, models, they have exactly the same structure, yeah? But for that AI to understand my intentions and those kind of aspects, yeah, that's very difficult, how you extract that information, you know? So I think, yeah, we have some roadblocks ahead.
Daniela has a comment here. I want to give Daniela a chance to say it herself. So I've just brought you into the panelist. Virginia, could you make Daniela give her let us see her? I don't know how you do this. Is that okay? I don't want to put you on the spot, Daniela, but oh, okay, maybe.
Oh, I'm sorry. I was muted.
Yeah.
Yeah, it's really late here, so I'm going to apologize and forego the camera. But Daniel, what you were saying was really interesting about the parametric model of offices and sort of what happened with parametricism in general. But my thought is that in essence, most offices use Revit. I mean, that is a parametric tool, but the know-how of using parametric tools lags far, far behind kind of a design direction that really is a sophisticated use of those tools. So I think what you're doing and what everybody here is doing is really important, which is that you're kind of lifting AI out of kind of the labor market, like doing technical tasks that are just mundane, and giving us a way to think about AI as a creative tool. And I really want to applaud you for that. I don't have a specific question, but I've just really, really enjoyed everything that you guys presented, and bravo to you.
Danielle, I should say, is on the European Graduate School PhD program, which is great because this is exactly what this platform is about introducing people to from all over the place to kind of to a common platform. I would just simply say, Daniela, that tomorrow we have Manu He, who is exploring the possibility of what they call in X-Cool ABC, which actually goes beyond BIM. And I suspect that there'll be new models coming out. I don't know how realistic that is, but I think it's an ongoing question about how it's developing.
Yeah, I think for sure we should not focus on the problem. I think we should. I mean, if you think about technologies that are transformative, they never thought of, this is going to be the end result. The end result all the time, it's something emergent. If you think about internet was not necessarily designed, or whoever invented it, it wasn't like having in mind that people are going to now interact the way that we interact today. That's an emergent thing in the end. So I think also in architecture, we should try to, and this is something that I have also with AIs and with data sets. My problem is that if you interpolate with AI, you are stuck in the same paradigm. That's a problem. And if you want to reinvent in a way the way we do things, you have to go outside somehow. You have to change the way you are thinking, because obviously the way we are thinking right now about AI and the problems that we have in the industry, we don't seem to figure how to solve the problem. So we have to come up with other solutions. It could be that you're saying, okay, locally I'm going to solve something, and because that tool or AI is so efficient locally, is going to have ripple effects in the industry, and it's going to change the way that the industry works. For example, there is that AI that checks for regulations, like if you're compliant. I don't know what will be the effect of that. So if I model something and I have automatically a sort of compliance in a way, a suggestion like, hey, here you have a problem, you're not compliant here, and so on. So is that going to affect, or it's going to create a sort of ripple? Is going to affect the way that offices are going to operate, or what exactly it's going to do? So I think that we have to look at those models more than trying to just say, that's the problem, so I'm going to try to solve it in a way, because most of the time it's like you're constrained already to a sort of way of thinking. So I think probably that would be the way to go with AI, with architecture, because you see, we start to talk about AEC, and we are already talking about how you collect data, and then you talk about Revit, and Revit, even if it's the same model, the same software for all the architects, one architect will choose to input 100 attributes in an object in Revit, another one will not. And then suddenly you have a problem with data, because one data point is represented by 50, the other one by 100. Yeah, so probably that's the wrong way to go about it. Yeah, probably we have to find other ways to think about how to solve these problems. Probably we have to like just be creative and just have this kind of leap, like just almost like leap of faith, yeah, when it comes to AI, and just like, hey, this could be something amazing. Can somebody point out a specific application today? No, probably not, because it's so far ahead in a way. But maybe those kind of jumps, those are going to help in a way to really change the way we operate in the industry.
Could I bring Benaz in briefly? Benaz is what is interesting, I think, about Benaz's background is she trained as an architect, and then she did a PhD in media arts in USC in the cinema school. You know, and I think what is kind of interesting. I mean, it's rather than simply sort of thinking about it, how we address problems within the building industry. To my mind, it's really actually a question of how do we deploy this architectural imagination and the kind of skills that we have as architects, and how can we kind of creatively invent what you do with AI. I mean, I don't want to be rude about engineers, but I think architects often can be a little bit crazy, and whether, you know, so maybe I could just ask Benaz that question about, you know, her experiences in terms of having an architectural background and what that might lead to. I mean,
yeah, I mean, there's a lot of great points here. I guess like for me personally, have been like very interesting to think about ways that we can use computational systems to think with ideas that it's important and it's critical and address larger issues. So it's kind of using technology not for the sake of, oh, it's cool to use technology or fetishize technology, but why do you use technology to do what? So for me, it's always that type of question that drives the project. And I think from that perspective, I'm very much skeptical of a lot of developments that you see, for instance, in Silicon Valley, in which a series of, you know, white men, typically engineers, sitting in the room making decision about future of many technologies. So for me, I think it's very important as a creative person to start tinkering with a lot of technology, that ways that allow for repurposing or twisting or sort of subverting the sort of mainstream conventional use of those technologies to something that allow for alternative narratives. So from that perspective, I mean, I sort of last comments that Daniel made, that speaks to me in a different angle, but it does speak to me because it's somehow about what you do with it. What do you do with this sort of AI technology? Like, is it good that we are now relying on this type of technology to do auto-completion of our text, our messages, our emails, or do you want to think about them critically? Who has access to technologies like that, and what kind of future would allow using this type of test? So for me, a lot of nuanced question like why and who and to whom will be benefit from such technologies become really, really important.
no,
Yeah.
no, go ahead. Sorry.
No, that was
No. I think, and I completely agree with that. I just want to mention two people that I think are really kind of good from that perspective. I think that on the one hand, I think Memo Acton is really a kind of very responsible person, and in terms of kind of like asking deeper questions about things, and then also being a bit critical about this obsession with NFTs. Everyone's saying, "Oh, we can make money out of this," and he's pointing out how environmentally unsustainable that is. And then you get people like Christoph Wodzitzko, who, of course, are using kind of pretty advanced technologies, but they're always being put towards asking sort of deeper kind of political questions, which to my mind is really the kind of the potential to kind of not only to get beyond the kind of straight fetishization, to use it creatively, but also use it critically. That's I think an important point.
I mean, there are two, maybe I can just say one more thing, that there are two main routes. One is you make an industry and you'll become mainstream to define an industry, meaning that if you're architects, you're working with developers to really elaborate your ideas in a larger context, or becoming a policymakers, or somehow you want to become mainstream or you're kind of staying away from this sort of mainstream and thinking about ways that you can create conversations or sort of develop public imagination. So for me, I see my role being in that space in which I'm less interested in really kind of becoming a mainstream or creating a practice which becoming mainstream that produce AI that it's in every variable or in every architectural spaces, but really start thinking that how I can create important questions that hopefully inform the future developments of many of these technologies. That's my personal interest.
I'd like to add an ingredient to what you were saying, Neil, before. So I'm a little bit older than you guys. I actually got my architecture degree in the 90s. And back then we didn't have any tools. In fact, AutoCAD just came on the scene in my last year in school. So to give you a perspective though, we were doing some really wild experiments, you know, with whatever we had, you know, whatever we could, however we could produce it. And all of us were reading Deleuze and Guattari's 1,000 Plateaus. And in a way, theory back then was driving design much more so than it is right now. And we were kind of pulling ideas and misreading a lot of things. Like Neil, you pointed out a day or two ago how we misinterpreted things like discrete design, or you know, Derrida's terminology and how he was baffled by why architects are inspired by him. But so a lot of that was a process of invention. And what I love about the explorations that I saw tonight is that you guys are literally inventing with the tools that you have right now and trying to imagine where that's going to leap forward. And I'm sure it's going to leap very far ahead, but I think people are going to look back, you know, 20, 30 years from now at these early experiments. And there is something very critical that happens early in a technology, which is that it's still the Wild West. We still don't have like something ossified and sort of mainstream. And a lot of things can still be invented. There's like a space for invention right now. So I always like to kind of, I like to harness things that are just coming out for that reason. That's all I wanted to say.
I mean, probably Pimlau. I mean, I'm actually curious about Daniel. Like Pimlau, like it's not like mainstream, right? Like it's. I remember when I was architecture students, one of the sort of superstar architects in my education was always Pimlau. Like there's this sort of creating this, it's like Zaha, like creating this public imagination that this is even possible. And I think that role in of itself is so important. So, I mean, I'm really honestly less interested in like using AI for like developers. It's scary to me, but the use of AI in a creative way to create a new possibilities, new imagination, new escape for next generations of architects coming on the scene, it's way more interesting because that's what Pimlau did for a lot of us, or is doing.
I mean, so Daniel, go ahead, Daniel.
No, it's okay. Go ahead.
No, I want to echo that because I, you know, it also echo what Daniel was saying. I mean, just speaking from a personal perspective, you know, I went into architecture because I'd seen the Sydney Opera House. You know, I'd seen things like this, and I thought, wow. And I was studying in the 80s in Cambridge, and you know, frankly, we were in postmodernism then, and it was only at the end of the 80s that we began to see the kind of stuff that Zaha was doing and so on. You know, and it was really like an electric shock. All of a sudden, you know, there were these crazy guys in Vienna, and I can remember in the 90s when I became an academic, and I was actually Wolf Pritz's thing about, you know, about you know, burning wings and things that he was doing as experimentation, and the kind of stuff that was going on at the AA at the time with Zaha and Rem and so on. This was kind of like reinvigorating architecture in a way, and I see that potential here in some senses. And I think it's really it's amazing that someone like Wolf Prix, who remains as kind of like dynamic and vital and energized as he was then now. And I think it's fantastic that he's kind of leading the way and being open to, because he could carry on just doing the same thing, but he's not content with that. He's sort of energized in a way. And I just got to say that I hugely admire Wolf for that. Yeah.
I cannot add anything to that.
Well, I will say that we are very fortunate. Wolf is going to be coming to our opening ceremony on the 26th, I think it is, of June. To have someone like that really pushing things and others are following. I think people are now going to pick up on that. I know that Patrick Schumacher is inquisitive about these things, and certainly Tom Main is looking to the possibility of that. And I think what we're going to see is going to be something, a game changer. And I think that we're going to see a completely different way of operating that's going to happen. And of course, these things are happening so quickly. 2 years ago, 3 yeyears ago, 2018, they put out a call for the British Pavilion for the Venice Biennale, and I put something in with Zaha Hadid Architects and with Google. I mean, this huge kind of a company was going to support it, and we didn't even get shortlisted. Now, all of a sudden, this has happened. It's exploding, I think, on the architectural scene, and the students are seeing how excited they are. I mean, Daniel taught my students in my studio, and they were so kind of energized by this whole thing. So I can see it as something that's going to really, who knows where it's going to lead to. But I think once you start igniting people's passion, then something happens in a very positive way. So yeah. Maybe we should wrap up. It's been going on for long. It was great. We had Emanuel, do you want to add anything before we wrapped up?
Yeah, maybe just a short one. I think it is indeed important to have these role models that seems, increasingly more open, and therefore allowing the younger generation to have a voice, have a kind of opinion, and they kind of support us from behind, and that's important. I think currently one of the, as you mentioned, things moves really fast, and I had this feeling that the younger generation tends to be a bit more reactionary. So, say today Eclipse comes out, and okay, let's just do it. This is a bit engineering way of thinking in a way, because you look at the tools, just do it. We don't think much, right? So I think we, to some extent, we also in parallel, which I suppose what Neil is kind of doing as a theorist, to kind of also step back at the same time and to kind of be critical about this. And going back to what Daniel mentioned about this interpolation. So if we bring that concept again into the conversation, the community, if we're just architects talking to architects, it's just interpolating between you and me. We can't get out of that latent space, right? So I think maybe a few weeks ago, I was with Daniel, we were talking about something with Matthias and Kai, and we're talking about who are the new kind of alliance that we should have. So in the days of the parametric design, it was the kind of engineers and that. So now, would it be the neuroscientists? Would it be the other comrades for this endeavor in order to make it a success? And therefore getting out of our self-interpolation. Yeah, and maybe last thing is, I think the school needs to play a major role. Even teaching my students at SUTD, they're kind of, sometimes have suspicious about, okay, what am I going to do with this AI thing? At the same time, excited, but then again, helpless, like this exploration, which is necessary. So I think once more schools start to kind of take on this as actually an important subject, then when they graduate, they will eventually change the industry. Yeah.
Maybe I could just add a final comment. We need to wrap up, but just to say one thing, and that is to say, I'm hoping that those who are watching, and there'll be this recording be there, and hopefully you, I'm sure I know that you've inspired people, and I just want to reflect on one moment that was about, I don't know exactly what it was. Maybe I'm just guessing, about 12 years ago. I don't know, maybe longer. And I gave a a talk in Iomincu in Bucharest. Iomincu was is still probably the leading school in Bucharest in Romania, and of course there's some very some of the professors were dinosaurs there. They really were, but the students were fantastic. Except some of them were a bit conservative. I don't know. I was showing Alice Andrushek's work. I don't know exactly what I was showing, but anyway, I was showing some stuff, and I got one question from one of the students said, but isn't the straight line sacred? And I thought, oh my God, isn't the straight line sacred? But I will say, there was one student there who somehow was inspired by something I'd said, and accidentally, I don't know, whatever. And that changed the course of his career, and that was Daniel Bolojan. And I'm just hoping that in this audience today, that you guys collectively will inspire people to change their outlook. And I think it's been incredible work. I think it's incredibly inspirational. And what I would also say, it's been done with an incredible seriousness. I mean, this is not easy. Don't think it's super. It is, and the fact that you've been grafting away at this stuff for so long, that the Deep Pimlau is not just like an overnight project, but it's been going on for years. I think is a sign of of how passionately and how committed you are. But I also got to say that the results were really absolutely astonishing. So I want to thank all three of our guests this evening, Daniel, Emanuel, and Benaz, and the comments in the chat just speak volumes, that you've inspired people. And let's hope that in those watching, we have the next generation of the Daniels and the Emanuels and the Benazes to come and take over, because I think this was really tremendous. I will simply say that tomorrow we have more. The debate is going to be about how this is going to be in the office, and I'm hoping to bring in actually one of our group from the attendees to come and to present his work as well, alongside Wan Yu He and Ruja Chatjian, who is a GSD student, will be presenting alongside Wan Yu He and Theodoros Galanis, who are both on the DDES at the FIU. So we'll talk more tomorrow. Also tomorrow morning we have Erin. Got a name now, so I'm blanking on the name. Sorry?
Erin Manning.
Erin Manning, sorry, Erin Manning, on the architecture and philosophy course. Sorry, it's been a long day. We've now uploaded a live stream onto the Digital Futures website. So please tell people about it, and we'll be putting all our lectures on the live stream as well. So thank you so much for being so inspirational. This has been a terrific session, and I just hope that I'm sure there are people out there that were hugely inspired by this. It was a really amazing session. So thank you, and thank you also to the Iceberg team behind that have been producing this, who were supporting this. Without your contribution, this could not happen. It's amazing what you're doing. So thank you, everybody, and see you tomorrow. Thank you.
Thank you, everyone.
Thanks. Bye. Bye, everyone.